This is going to be part 2 of respiration, the inhalation exhalation process. So let's begin talking about the parts of the body that we need to know to be able to talk about inhalation and exhalation. The two parts of breathing, breathing being the first part of 4 parts of respiration. Breathing, external respiration, internal respiration, and then finally cellular respiration. So the diaphragm is a thin sheet of muscle, relaxed. It is dome shaped. It also separates the two cavities, and sorry for the spelling mistake, separating the thoracic, the chest cavity, from the abdominal, the stomach cavity. Intercostals are muscles that we like to eat in the summertime. These are the muscles that surround your ribs. So when you eat spare ribs, barbecue ribs, right, you're gnawing on the intercostals. And these muscles cause our chest cavity or thoracic cavity to expand in the inhalation along with the diaphragm. Pleural membranes, there are 2 of them, and I still want to write here, so come back pen. 2 of them, I didn't set my timer, sorry, quickly going to do that. 2 of them, they line the thorax. They also create a seal. So just like a Tupperware lid on a Tupperware, it creates a seal. It also reduces abrasion, and abrasion is what's going to happen if your ribs rub against your lung tissue all day long as you inhale and exhale. So these pleural membranes make it a smooth process instead of one that causes friction. Stretch receptors are nerve cells that line the alveoli, so on the inside of the alveoli, to tell the brain, signal to the brain when they are fully expanded. We also have stretch receptors in our urinary bladder, right, that tells our conscious brain when fully expanded. So stretch receptors are there to finish the inhalation when the alveoli are fully expanded. So the process of inhalation, important key things, you made your little model with your cup and your diaphragm / glove, rubber glove. In inhalation, the diaphragm, couple words we want to know or associate with this, going back, the couple words are, it is contracting, it is pulling down, it is becoming flattened because at rest it is dome shaped. So when it contracts, it pulls down. Negative pressure is created inside this cavity. It's sealed. Remember, the pleural membranes and the diaphragm seal it. So when we increase the volume of our thoracic cavity, the pressure decreases and air moves to equalize this difference in the pressures, and the air rushes in, expanding our alveoli. The other group of muscles, the intercostals, move the rib cage up and out, up and out. So diaphragm, contract, pull down, and flatten. Exhalation is the relaxation part of our breathing. Our diaphragm becomes dome-shaped, and I hate my pen sometimes, so it becomes dome-shaped. It moves up, it relaxes. So it's not flattening. So when it's going back to its normal dome-shaped, this is relaxation, creating inside positive pressure. This is going to push the air out, and also our intercostal muscles will relax, the rib cage down and in, diaphragm moves up. Obviously, breathing, right, is a continuous process. We don't breathe in, stop, think about it, and then breathe out. It's a cyclic activity. So we want to just remember the contraction part is inhalation. It's active, so muscles are contracting to make us inhale. When we relax, this is passive, our muscles are relaxing, and this causes the exhalation. Who controls this? The medulla oblongata, the reflex center of our brain. So just like the heartbeat, breathing is a reflexive action. It detects two levels of gases as its primary trigger for setting your breathing rate. So how many breaths are you taking in a minute? Are you breathing slowly? You're at rest, you're sleeping, you're sitting on the couch, being a couch potato, or you're being active, running down the street, training for your marathon. So the primary trigger that the medulla oblongata uses to set our breathing rate is the level of the hydrogen ion and the level of carbon dioxide found in the bloodstream. Right? This is not found in the garbage or out there in the air. It's inside of our blood. So the medulla oblongata, warning bell for me to finish up. So medulla oblongata senses, because remember, hydrogen ions are like pH, so more hydrogen would make our blood acidic. They are going to control the two muscles, the two sets of muscles, the intercostals and the diaphragm. So the medulla oblongata sets the pace at which these contract. Secondary to the primary the setting rate for the medulla oblongata is oxygen levels. So this is a secondary, not the primary thing that the medulla oblongata uses. This is second to carbon dioxide and the hydrogen ions. It is chemoreceptors in the carotid artery and the aortic arch, the levels of oxygen. So the amount of oxygen in your blood does not set your breathing rate. It is the amount of the waste gas, carbon